Hello guys, this is Justin Bibilan and welcome to this episode of Don't Panic, It's Organic.
Ilalaban kahit kanino, oo, simple lang ako at malabo mong magtipuhan. Kaya okay nang kahit sa FB mo lang mapusuan. Kasi di na mapigilan ng sariling mapaibig sa iyo. Ano ba to? Gusto ka laging
Hello, I'm back. This is Justin Bibilan, aka Organison11A. From this episode, we will learn about the first family of organic compounds, which are alkanes. So what is an alkane what are alkanes? Remember that alkanes belong to the family of organic compounds or hydrocarbons, which are called an aliphatic hydrocarbons. So alkanes are saturated hydrocarbons. When we say saturated, it only contains a carbon to hydrogen single bond and carbon to carbon single bond. Okay? So it is a hydrocarbons, it only contains hydrogen and carbon. If it is a saturated, then therefore it contains a carbon to hydrogen and carbon to carbon single bond. So all the carbon to carbon bonds there are actually single bond. Then therefore it is an alkane. The formula for alkane is CnH2n plus 2, where N is the number of carbon atoms in the molecule. So the simplest alkane is methane, which only contains a one carbon. So if we are going to get the molecular formula for methane using this formula, which is CnH2n plus 1, so therefore if methane contains only one carbon, then therefore N is equal to, what is the value for N? That would be equal to 1 because your N there is the number of carbon atoms. So methane is the simplest alkane where it contains only one carbon. So C1H, following the formula, which is CnH2n plus 2, then that would be 2 times 1, then that would be 2 plus 2. Okay, so that becomes C1H4. But in mathematics, if it is 1 already, then we will not put the number 1. That would be an understandable that your carbon there is actually 1 carbon. That becomes CH4. So 2 plus 2 is 4. Then this now is the molecular formula for methane. Easy, right? For ethane, it contains 2 carbons. So that becomes N is equal to 2. So what would be the molecular formula for ethane? C2, okay, H, that would be 2 times 2, that would be 4. So 4 plus 2, that becomes C2, C2H6. Okay, C2H6. So this is now the molecular formula for ethane. So it's very easy. Am I right? So the next one is propane. So it contains 3 carbon. So notice 1, 2, 3. So 3 carbons, the chemical formula would be C3H. So 3 times 2, that would be 6 plus 2, that becomes 8. Okay, for butane, it contains 4 carbon. Okay, so 4 carbon, then this contains 5 carbon, then this contains 6 carbon. So from the root word itself, pent, and you notice that its last letter, 3 letter is A, which is from the word alkane. Okay, so if a hydrocarbons end with A and E, then it is an alkane. Okay, you have methane, ethane, propane, butane. So butane has 4 carbon. Pentane from the root word pent, which means pentagon or 5 sides. So that is a 5 carbon alkane, pentane. Hexane from the root word hex, which means from your mathematics hexagon, it has a 6 sides, so it's a carbon with it is a hydrocarbon or an alkane with 6 carbon. You have 7, which is heptagon, oct, which is 8, non, which means 9, and dec, which means 10. Okay, so you can do the rest for the molecular formula for butane, pentane, hexane. Okay, you can do that already. You just use this formula. Okay? So we can represent the formula for alkanes using molecular formula, structural formula, condensed formula, and line formula. So how do we do that? For example, write the molecular formula and draw the structural formula, condensed formula, and line formula of butane and pentane. Okay, remember earlier, butane has a 4 carbon. Okay, 4 carbon, while pentane has a pent, that would be 5 carbon. Okay, so molecular formula, you just use the formula for alkane CnH2n plus 2. Okay, so therefore for butane, the molecular formula would be C4H8. 2 times 4, that is 8 plus 2, C4H10. So this is now the molecular formula for butane. Okay, how about the structural formula? So the structural formula is actually what we call the line band structure. From our earlier discussion about Kekule structure or the line band structure, that is what we call the structural formula. Okay, so remember that is C4H10. So in writing your structural formula, first you're going to do is you have to line up all the C. So how many C's are there? There are actually 4 C. And remember, your alkane is carbon to carbon single bond only. Am I right? So this is carbon to carbon single bond, carbon to carbon single bond, and carbon to carbon single bond. Why? It's because this is a saturated hydrocarbon. Okay? So that is already now the backbone of our structural formula for a for butane. Okay? So we have a carbon to carbon single bond, carbon to carbon single bond. So the next one is how do we put those hydrogens? There are actually 10 hydrogens. Okay, so we're done with 4 carbons. So remember that your carbon is a tetravalent carbon. That means it only binds to a total of 4. Okay, so for example, this carbon, it already bonds to the carbon 1. So it needs how many remaining bonds? 3. So that it would have a total of 4. Okay, so 1, 2, 3, 4. How about this carbon here? You have 1, 2. So the remaining would be 2. Okay, so that it would have a total of 4. How about this? It already has 2 bonds. So therefore, it has a remaining of 2 bonds. And the last carbon would have, it actually has already 1 bond. So therefore, the remaining would be 3 bonds. That's correct. And those bonds there are actually coming from your hydrogen. So you can now put the hydrogen there. You can now put that hydrogen. You can also put the hydrogen. And this one also, hydrogen. Hydrogens are everywhere, especially in the air. Okay, hydrogen. Very important, hydrogen. Okay, so that's it. So then check your molecule or check your structure if it contains 4 carbon and 10 hydrogen. So 1, 2, 3, 4 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 hydrogen. Then this one now is actually the structural formula for butane or C4H10. Okay, so remember that your carbon should have a total of 4 bonds because it is actually a tetravalent carbon. Okay, so the next one is the condensed structural formula. So I will just erase this first to allocate a space. Okay, so how do we write the condensed structural formula? So from your structural formula, I will erase this portion. Okay, from your structural formula, you can actually write the condensed formula. So when you say condensed, all of this the composition of this one are actually being condensed. So we can slice this like that. Okay, we can slice that. The 4 carbons, there are actually 4 carbons, so we can slice the 4 carbons. So here, there, that's the second slice, and the last slice would be there. Okay, so you notice that the portion here is actually how many carbon? 1, then you have 3 hydrogen. So we can actually write that as CH3. Okay, CH3. Okay, the next one here is this one. How many carbon? 1 and 2 hydrogen. So therefore that is would be CH2. Okay? So the next one is also a CH2. Okay, so CH2. Oh, I have no space now. Okay, I will just erase. I will just erase this. Okay, erase that. That's done already. And the last portion would be what? The last portion would now be this portion here. 1 carbon, 3 hydrogen. That would be CH3. Okay, then you're done with the condensed formula. Then you need to check your answer. 4 carbons. 1, 2, 3, 4. 10 hydrogens. 3 plus 2. That is 5 plus 2, 7 plus 3, 10. So therefore, this is now your condensed formula. Then you're done with your condensed formula. Okay, from your condensed formula, you can actually write the line formula for pentane. Sorry, I'm sick. Okay, so we can write the line formula for butane. So line formula is just a line. Okay, you can actually make it a line. Okay, the line should be like it's an alternating line. Like for example, if if you are starting with that, then the next one should be down, and the other one should be up, then down. So it's like a zigzag line. Okay, so it's a zigzag line, but each line there represent your carbon. Okay, each point here, for example, this point is another carbon. The second point there is another carbon, and this one point here is another carbon. Then that would be another carbon, and this one would be another carbon. In this line formula, you're actually not portraying the number of hydrogens, but only the carbon. So it's understandable that hydrogens are there, but we are not actually giving emphasis to the hydrogen. Only your carbon. So it's understandable that hydrogens are actually there. So for example, this butane compound. Okay, so how many carbons are there? So there are 4 carbons. So we can write it as 1, 2, 3, 4. Then you're done. This is already the line formula or the zigzag formula for butane. So 1, 2, 3, 4. So it's understandable that this carbon here contains a 3 hydrogen. It's also understandable that this carbon here contains 2 hydrogen. It's also understandable that this carbon here contains 2 hydrogen. And the last carbon there contains 3 hydrogen. Then you're done. Okay? So it would be your next uh, example for pentane. So that is already your activity now. Okay, if you want to proceed to the pentane, then you can also. Okay, I will just give you the answer right now, but then you can pause this video for you to have to allocate the time so that you can get the molecular formula, the structural formula, the condensed formula, and the line formula of butane and pentane. Okay, our next example is this one. So write the molecular formula and draw the structural formula and condensed formula of the following molecule. So given the line formula for 2,3-dimethylhexane, so we are going to write the molecular formula, draw the structural formula, and the condensed formula of 2,3-dimethylhexane. So before we're going to write the molecular formula, so we can first write down or draw the structural formula for this compound. Okay, so we knew that each of this point here is actually contains carbon. So that point there contains carbon. This one also contains carbon. That one contains carbon. And this portion here also contains carbon. This one here contains carbon. This one also contains carbon. And that one also contains carbon. Okay, so we are going to write first the structural formula. So given that 1, 2, 3, 4, 5, 6. Okay, let's going to first count the carbon. 1, 2, 3, 4, 5, 6, 7, and 8 carbons. Okay, so in this case here, this one is actually a straight chain alkane. That is a straight chain alkane. So how many straight chain alkane is this? One, how many carbons? 1, 2, 3, 4, 5, 6. So we're going to write 6 carbons. 1, 2, 3, 4, 5, and 6. Okay, and each of these carbon is actually a single bonded to another carbon. That is carbon to carbon single bond. Okay, so I will just erase this first. All right. Okay, next is, I told you earlier or on a previous topic that there are actually substituted hydrocarbons. Am I right? So in this case, this portion here is actually substituted hydrocarbon. So the hydrogen there from this carbon and that carbon is actually replaced with in an atom or group of atoms. So in this case, it has been replaced by another carbon. And in this case, the hydrogen there is also replaced by another carbon. So where is it? It's actually on 1, 2, 3, 4. So 1, 2, 3, 4. So there is a carbon here attached to that carbon. And on the fifth is also another carbon attached to it. Okay? So that's it. So there are how many carbons in total? 2, 4, 6, 8. So 2, 4, 6, 8 carbons. Now for hydrogen, okay, I told you that your carbon is a tetravalent carbon. So therefore, you would expect that carbon would have a bonds with 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 the other carbons or other atoms in only 4 bonds. Okay, so this carbon has already have 1 bond, so the remaining bonds would be 3. This carbon 2 bonds already, so the remaining would be 2. This carbon has also 2 bonds, then the remaining would be 2. That carbon has already 3 bonds, so the remaining would be 1 bond. That carbon is also 3 bonds, so the remaining would be 1. And the last carbon is 3 bonds. And also don't forget your substituent. Your substituent has also carbon And to complete its 4 bonds, so it has a remaining of 3 bonds. And also the last carbon here has also 3 bonds. Then you're going to write down the hydrogens. Okay, the hydrogens. Okay, there's so much hydrogens here. So just wait for a moment. Okay, hydrogens are everywhere. Okay, hydrogens. OMG. So I'm not quite good in this pen. Oh, there's still hydrogen here. Okay, and you have another hydrogen. Okay, and the last hydrogen here also. Okay, another hydrogen. Okay, and the last one. Okay. Okay, I transfer it to another slide to fully see it in this manner. Okay, so this is now the structural formula for 2,3-dimethyl hexane. So we have 8 carbons in total. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we are going to write the molecular formula for 2,3-dimethyl hexane. So how many carbons are there already? There are actually 8 carbons, so you would expect that it's C8. Okay, C8. How many hydrogens? Okay, how many hydrogens? You have 3. This is 2, that is 5, 7. You have 10, 11, 12. And this is 15 plus 3, 18. So C8, H18. So this is now the molecular formula for the 2,3-dimethylhexane. Now let's move to the condensed formula. Okay, how do we did the condensed formula? We're going to slice the structural formula, this portion, that portion, this portion, that portion, this portion here. We have another portion there, and the last portion is there. Okay, so we're going to write this first. That is actually C, C, H. Okay. How many hydrogen? There are 3. Okay. The next one is C, H2. Okay. C, H2. The next one is CH2. Okay, CH2 again. Then you have your CH. Okay. CH. Because in CH, your carbon is actually bonded to CH3. So that carbon there is actually bonded to another CH3. So always remember that that bond should be bonded to your carbon because that is CC bond, huh? Not with your hydrogen. So you should emphasize that this bond is from carbon to carbon bond. Okay, the next one is you have a CH. Okay, you have a CH. Where is that CH? That portion there. And this C is actually bonded with another CH3. Okay, that is bonded to another CH3. Then you have the last portion that is CH3. Okay. Then you're done. This is now the condensed structural formula for 2,3-dimethyl-hexane. So we're going to check first. How many carbon? 1, 2, 3, 4, 5, 6, 7, 8. Correct. How many hydrogens? 3 plus 2 is 5 plus 2, 7 plus 3. That is 10, 11, 12 plus 3. That is 15 plus 3, 18. So this is correct. Then you're done.